Analysis of O2 saturation. The hypothesis for O2 saturation was that it would increase and then there would be a plateau. This graph shows a very different outcome of the data. This data shows that the O2 saturation in all the blood started between 100% and 82%. Against normative data, the O2 saturation must be kept above 82% to maintain healthy cells. There was then a decrease in the O2 saturation and an increase, so there was a fluctuation during the exercise. However, in this graph we can see that there is a distinct plateau in all three data lines as there is only one very little change in O2 saturation between 9 and 20 minutes, where the O2 saturation remained between 95 and 100%. The reasoning for this strange dataset could have been human error. Some readings could have been taken incorrectly. The method for this test was taking a reading from a pulse oximeter that was placed on the subject's finger. This is where the data could have been taken incorrectly, because for a while we were reading the O2 saturation as heart rate. So against normative data, the only anomaly that stood out was that the O2 saturation decreased, which shouldn't have happened because the breathing rate was increasing, which would mean more oxygen is being breathed in as well as an increased heart rate. The heart rate was also recorded with a pulse oximeter, and we also used a heart rate monitor. The patterns of these graphs are very different from the predictions that we made in our hypothesis. In our hypothesis, we predicted that the heart rate would gradually increase and then plateau. However, this is different from the data that we have collected. The heart rate for all three subjects suggests that they were not working at a steady state. If they were, then this would mean that the heart rate would plateau because the demand for oxygen is not increasing. However, this is different on the graph because there are very large fluctuations within the graph, and there is only a plateau at the end of Rachel's heart rate. Her resting heart rate was 128 beats per minute, which is relatively high for pre-exercise. However, this could have been due to anticipatory rise. 2 minutes into the exercise, she has a spike to 159 beats per minute, where this rapid increase suggests that she is using the wrong energy system. The last 4 minutes shows fluctuation and also a 9% decrease and suggests that she is working too hard and cannot maintain the exercise. The other section that looks slightly like our hypothesis was the part where Luke's heart rate was gradually increasing after 8 minutes, but it did continue to increase, which means that he was increasing the demand of the exercise and was not working at a steady state or aerobically. Luke's heart rate performs a similar pattern to what was predicted. His heart rate does increase gradually from 90 beats per minute to 120 beats per minute, which is a 35% increase. However, there is a consistent fluctuation in his heart rate, which suggests his work rate is constantly changing and is increasing the demand for oxygen as he may be working anaerobically. As well as this, Billy's heart rate was constantly jumping up and down, which meant that he was always changing the rate at which he was working. This could also suggest that it was the fault of the people carrying out the test because there was trouble with the readings, as well as trouble concerning maintaining a level of exercise. Billy's heart rate also rises by 8 beats per minute, which suggests that he had a gradual increase in heart rate. However, his next value was 152 beats per minute, which suggests that he is using the wrong energy system. The Borg scale, or rate of perceived exertion, was a self-assessment of how hard the subject was working at different parts of the 20-minute test. The level that would have been a steady state level would have been from around 13 to 16. As we can see, most of the participants were working at a steady state level. However, there was a large amount of fluctuation, and many participants were either working above or below the optimum level of RPE. This meant that many people were not working at a steady state for a long period of time, and could be why some results were off, because the participants were not working at a level between 13 and 16 for a maintained amount of time. In this graph, we can clearly see the fluctuations in blood pressure from this test subject. The blue represents systolic blood pressure, and the orange represents diastolic blood pressure. Unfortunately, we were only able to gather data for one test subject, as there were too many errors with the other results. As we can see here, there seems to be a pattern which seems different and incorrect, because there are too many fluctuations. As well as this, systolic pressure should not decrease during any increase in exercise. Systolic pressure should not decrease at any point during the exercise. The decrease in diastolic pressure seems accurate because in our hypothesis and research we found that there should be a decrease in diastolic pressure due to vasodilation. Analysis of lactate levels in the blood. This was carried out by our teacher, taking a sample of blood from the subject every 5 minutes. Lactate levels in the blood refer to OBLA, which is onset blood lactate accumulation, which is how much lactate builds up in the body during exercise. For the orange and grey lactate levels, there seems to be an accurate level of lactate in the body. This is because when we carry out steady-state exercise, there is a constant supply of oxygen, because the body is carrying out aerobic exercise. The presence of oxygen will mean that the lactate level should be very low, even when it is produced, because oxygen will eradicate it. The reading of the grey line is accurate, and like the hypothesis that was stated, there should be a decrease in lactate levels because aerobic exercise is being carried out and the oxygen should eradicate the OBLA. For the orange and blue line, their lactate levels should be much lower because oxygen is present. This is a referral to the experimental method because there should have been a much lower lactate level. This suggests that the two participants were working anaerobically and the absence of oxygen led to a buildup of lactic acid. The grey line was Luke's results. This participant's resting lactate was 9.3 and the next reading was 20.9, which suggests he was working anaerobically. As well as this, Rachel had a similar pattern where her lactate levels increased. Analysis of breathing rate. For breathing rate, there seems to be a similar pattern for all three participants to the hypothesis that I stated earlier. I predicted that the breathing rate should increase due to an increased resistance and then there should be a plateau because the participant has reached steady state. There should be a plateau in breathing rate because there needs to be a constant supply of oxygen, and during steady state there is a constant supply and the demand is not increasing, so the breathing rate should remain the same. These breathing rates for the orange and grey lines seems to be accurate and very similar to each other. As well as this, they both follow the same pattern where there is an increase and then a plateau, which means they've reached a point of steady state. However, there is an anomaly in this data set, which is the blue line. This participant has a very steep increase, whereas the other two participants have a much more gradual increase and then a plateau. This is different to the blue data line because there is a very steep increase and then a slightly shallower increase. However, the breathing rate continues to increase during steady state exercise, or during the exercise, which means that he was not working at a steady state and he was working anaerobically for a large amount of time. We can see this because there is an increased demand in the exercise because the body needs more oxygen. The blue dataset does eventually plateau, but it should be much sooner, and there should not be an increase in the demand for exercise. The anomaly in these results is referring to the experimental method, where the readings may have been incorrect, and we were making the participant working harder than required. This is also suggested because at one point, his dataset said that he was breathing more than 1 breath a second. Respiratory analysis. During steady-state exercise, we predicted there will be a rapid increase in breathing rate, and it will then plateau. O2 saturation during steady-state exercise will increase, and it will then plateau. For breathing rate, we said there would be an increase during steady-state exercise, and there would then be a plateau. The method for this was counting the breath of the participants, as well as measuring the lactate and O2 saturation in blood at different intervals. The breathing rate for Luke was the most similar against normative data, and the hypothesis. There is a clear plateau at around 2 minutes into the exercise after a clear increase. This suggests that Luke was working at a steady state during the exercise. However, there was a point where his breathing rate did increase at different points in the exercise towards the end of the test. As well as this, for Luke, we can see that there is a similarity between the breathing rate and the O2 saturation during the exercise. O2 saturation is high and remains high whilst he's carrying out the exercise, which suggests that he is working aerobically because there is a constant supply of oxygen. However, there is one dataset that doesn't seem to correlate with Luke's breathing rate, which is his lactate levels. His lactate levels start at 9.3% and then rise to 20.9%, which is an anomaly. This is because the lactate levels should not be this high if the breathing rate is high and the O2 saturation is high. This suggests that the readings that were taken were perhaps noted down incorrectly due to equipment being faulty. As well as this, another explanation could have been that he carried out exercise before the test, which means that he could have had a build-up of lactic acid that was shown in the readings. Rachel's breathing rate also showed a similar pattern to Luke's breathing rate. There was an increase and there were points where there was very little fluctuation, which means that her breathing rate would have been considered to plateau, which suggests that she was working at a steady state. However, there is no clear plateau and there is a constant increase which shows that she was not working at a steady state. Even though her breathing rate increased from 10 to just below 20 breaths per minute, which is considered a plateau for her O2 saturation, which is considered a plateau, her O2 saturation was constantly changing and there was even a decrease. As well as this, there was a decrease in lactate levels, which could suggest that she was working aerobically because the presence of oxygen would have eradicated the lactic acid. Another explanation for why her O2 saturation was a strange pattern could have been the experimental method, where the readings were taken down incorrectly or the equipment was not giving the correct readings. The last breathing rate analysis that had a very anomalous result was Billy's readings. His breathing rate rapidly increased and continued to increase. His breathing rate pre-exercise was 20 breaths per minute and rapidly increased to 45 breaths per minute, and then gradually increased until it began to plateau at around 60 breaths per minute. This could have been because of incorrect experimental method This could have been because of their experimental method. At the start of the exercise, the readings could have been incorrect, which means that the administrators would have told Billy to increase his rate of exercise. This means that for most of the test, Billy was working anaerobically, and this could have suggested why he had a high lactate level, because there was not a continuous supply of oxygen to eradicate the lactate, because he was not working at a steady state. There is a major anomaly in Billy's results. This is because at 12 minutes later, Billy is breathing over 1 breath per second, which is impossible. This suggests that the readings were incorrect, and this gave us inaccurate data.